Technology Risk Part 6. This episode has 23 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Monitoring or reporting. What should a risk dashboard include? Here's a strong way to approach it. A good dashboard includes top risks, risk trend, CREs, control health, overdue remediation, audit findings, exceptions, vulnerability slaw status, incident themes, cloud posture issues, and business impact. It should be role-based. Executives need trends and decisions, while engineers need actionable details. Nice. Let's continue. Question 2. Monitoring or reporting. How do you report risks to leadership? Here's a strong way to approach it. I report in business language. What can happen? What business process or customer impact is at stake? Severity, trend, owner, decision needed, and timeline. I avoid deep technical detail unless needed, but I keep evidence ready. I also distinguish between accepted risk and unmanaged risk. Great. Moving on. Question 3. Monitoring or reporting. Explain key risk indicators, CREs. Here's a strong way to approach it. CREs are measurable signals that show increasing or decreasing risk exposure. Examples include number of critical vulnerabilities past SLA, percentage of production systems without logging, public assets discovered, privileged access exceptions, or failed backup tests. CREs help leadership act before incidents occur. Alright, next question. Question 4. Monitoring or reporting. What is the difference between CREs and KPIs? Here's a strong way to approach it. A KPI, key performance indicator, measures how well something is performing against a goal, deployment frequency, uptime percentage, feature delivery speed. A CRE, key risk indicator, measures the level of exposure to a potential future problem, number of overdue critical vulnerabilities, percentage of access reviews not completed on time, serving as an early warning signal rather than a performance measure. So a healthy KPI can coexist with a deteriorating CRE signaling trouble ahead. Let's keep going. Question 5. Monitoring or reporting. How do you monitor cloud security posture? Here's a strong way to approach it. I use tools like Security Command Center, Cloud Asset Inventory, org policy reports, logging, vulnerability scans, IAM analysis, public exposure checks, IAC scanning, and SIM correlation. I also define ownership so posture issues become tickets with SLA, not just dashboard noise. On to the next one. Question 6. Monitoring or reporting. What SIM tools have you used? Here's a strong way to approach it. If answering from experience, name the tools you used, such as Splunk, Chronicle, QRadar, Sentinel, or Elastic. A strong answer explains how logs are collected, normalized, correlated, alerted, and investigated. If I have limited hands-on experience, I would be honest and explain transferable logging and alerting work. Good. Here's another one. Question 7. Monitoring or reporting. How do you prioritize vulnerabilities? Here's a strong way to approach it. I prioritize by CVSS, exploitability, internet exposure, asset criticality, data sensitivity, compensating controls, known active exploitation, and business impact. A critical vulnerability on an internet-facing production service gets priority over the same CVE on an isolated non-production asset. Nice. Let's continue. Question 8. Monitoring or reporting. What is risk trending? Here's a strong way to approach it. Risk trending tracks whether risk is improving, stable, or deteriorating over time. It helps avoid one-time reporting and shows whether remediation is working. For example, a decline in overdue critical vulnerabilities is positive, while repeated public bucket findings show a systemic control gap. Great. Moving on. Question 9. Monitoring or reporting. How do you communicate business impact? Here's a strong way to approach it. I translate technical issues into outcomes such as service downtime, customer data exposure, regulatory breach, financial loss, delayed delivery, operational toil, or reputational damage. For example, instead of saying IAM is too broad, I say a compromised service account could access customer data across multiple projects. Alright, next question. Question 10. Architecture review. What do you review before approving an architecture? Here's a strong way to approach it. I review business criticality, data flows, authentication, authorization, network exposure, encryption, logging, monitoring, resilience, backup, DR, secrets, third-party dependencies, compliance needs, CI or CD, operational ownership, and incident response. I also check whether controls are testable and evidence can be produced. Let's keep going. Question 11. Architecture review. How do you evaluate third-party risk? Here's a strong way to approach it. I assess the vendor's security posture, data access, compliance certifications, contract terms, SLAs, incident notification, business continuity, location of data, integration method, access model, and exit plan. I also check whether the vendor becomes a critical dependency for production or regulated data. On to the next one. Question 12. Architecture review. What questions do you ask during architecture reviews? Here's a strong way to approach it. I ask what data is processed, who can access it, what is internet facing, what can fail, what can be abused, how secrets are handled, how logs are captured, how recovery works, how changes are deployed, and who owns operations. I also ask what assumptions have not been tested. Good. Here's another one. Question 13. Architecture review. How do you identify single points of failure? Here's a strong way to approach it. I map dependencies across compute, database, network, DNS, identity, CI or CD, third parties, and operations. I look for components without redundancy, backups, failover, capacity alternatives, or manual workarounds. Then I validate whether failure modes have been tested through drills or incidents. Nice. Let's continue. Question 14. Architecture review. Explain high availability from a risk perspective. Here's a strong way to approach it. High availability reduces the risk of service disruption by designing systems to survive component failures. It includes redundancy, load balancing, health checks, multi-zone or multi-region design, autoscaling, graceful degradation, and tested failover. From a risk view, HA should match business criticality and cost tolerance. Great. Moving on. Question 15. Architecture review. Explain disaster recovery. Here's a strong way to approach it. Disaster recovery is the ability to restore technology services after a major disruption. It includes backups, replication, recovery procedures, DR environments, roles, communication plans, and testing. DR is measured by RTO and RPO and should be validated through exercises, not just documentation. Alright, next question. Question 16. Architecture review. What is the difference between RTO and RPO? Here's a strong way to approach it. RTO, recovery time objective, is how long the business can tolerate a system being down before recovery must be complete. It drives how fast your failover or restore process needs to be. RPO, recovery point objective, is how much data loss is acceptable, measured in time. It drives how frequently you need to backup or replicate data. A near zero RPO requires continuous replication. A short RTO requires automated, well-rehearsed failover, and the two targets together shape the entire DR architecture, not just the backup schedule. Let's keep going. Question 17. Architecture review. What is business continuity planning? Here's a strong way to approach it. Business continuity planning ensures critical business operations can continue during disruptions. It is broader than IT disaster recovery and includes people, process, vendors, communication, alternate workflows, and business priorities. Technology risk teams help align systems recovery with business continuity needs. On to the next one. Question 18. Architecture review. Explain zero trust architecture. Here's a strong way to approach it. Zero trust assumes no user, device, network, or workload is trusted by default. Access is continuously verified using identity, context, least privilege, device posture, segmentation, and monitoring. In cloud, this means strong IAM, workload identity, network segmentation, policy enforcement, and continuous logging. Good. Here's another one. Question 19. Architecture review. What are common architecture risks? Here's a strong way to approach it. Common risks include unclear ownership, weak IAM, public exposure, missing encryption, no logging, single points of failure, hard-coded secrets, untested backups, poor data classification, third-party dependency gaps, weak CI or CD controls, and lack of rollback or incident procedures. Nice. Let's continue. Question 20. Audit or compliance scenarios. An auditor finds that production access is shared among developers. What do you do? Here's a strong way to approach it. I would treat it as a serious access control issue. First, identify where shared access exists. Remove or disable shared accounts where possible. Assign named accounts. Enforce MFA or SSO. Implement RBAC and just-in-time access. Review logs for misuse. Document remediation. And provide evidence to audit. I would also prevent recurrence through policy and periodic access reviews. Great. Moving on. Question 21. Audit or compliance scenarios. Terraform state contains database passwords. How would you fix this? Here's a strong way to approach it. I would rotate the exposed passwords, move secrets to secret manager or vault, restrict and audit state access, ensure remote state encryption and locking, remove secrets from Terraform variables and outputs, and update modules to reference secret resources safely. I would also check commit history, CI logs, and backups for further exposure. Alright, next question. Question 22. Audit or compliance scenarios. Jenkins stores credentials in plain text. What actions would you take? Here's a strong way to approach it. I would rotate the credentials immediately, move them into Jenkins credentials store or an external secret manager, restrict access, review logs for exposure, update pipelines to avoid printing secrets, patch Jenkins and plugins, and add audits for credential usage. I would also review whether Jenkins has excessive production permissions. Let's keep going. Question 23. Audit or compliance scenarios. Kubernetes dashboard is publicly accessible. What risks exist? Here's a strong way to approach it. The risks include unauthorized cluster access, workload manipulation, secret exposure, privilege escalation, data exfiltration, and production disruption. I would restrict network access, require strong authentication, review RBAC, inspect audit logs, rotate exposed secrets if needed, and consider whether the dashboard should be disabled entirely. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.